Good morning, students. Class 9. We discussed in the previous video, in the previous class, till Newton's third law of motion. Today, I am going to discuss several situations of your daily life where Newton's third law of motion is applicable. So, student, first situation, that a rubber ball rebounds when struck against hard floor. Yes, you would have seen that if you're having a ball in your hand and when you throw the ball, that ball carries a momentum and ball comes back with the same momentum after striking the wall. What happens there? Students, we could say that when you strike a rubber ball against a hard ball, the ball exerts a force. Alright? The ball is exerting the force on the wall, that is action force, and when after striking it comes back to you, that force is reaction force. So students, we could say here there is the application of Newton's third law of motion, action and reaction. Okay, now there is another question number 2. You feel a backward jerk on your shoulder when you fire a gun. Yes, it happens. It happens, yes or no? Suppose this is a gun and so this gun, what happens? There is a one bullet, okay, and that bullet, when it comes out and goes away, so when the bullet is going away, this is action. You have triggered the gun and the bullet is coming out of the gun. It is called action. So this action force implies another force of equal magnitude in the form of reaction force, and that reaction force is what? In the backward direction, so which is called as jerk. So your shoulder must be stronger for tackling of the gun. So students, we can see here, we can understand, when the gun is fired, the bullet goes out due to the force applied on it through the trigger, and this is action force. Alright? Now, the gun recoils backward due to the reaction acting on it in the opposite direction. Yes, this in the opposite direction, which is in the form of reaction, and this is jerk. So that is why the shoulder must be stronger. You have seen that policemen always hold their gun along with the shoulder. So that's what the strongest possible reason we could say here. Now, number 3. How do rockets or jet planes work? Students, you would have not seen jet planes or rockets in real life, but there are so many occasions in the televisions, through the news channels, some rocket launching occasions we have witnessed on the news channels. Yes, what happens there? Students, suppose that this is a rocket. Okay, this is a rocket, and what do you know, in this rocket there is one fuel which is called liquid hydrogen fuel. Liquid hydrogen fuel. So liquid hydrogen fuel inside the rocket is what? Coming out of the nozzle from the rocket. So this is what? The force getting applied to the hydrogen gas fuel. This is called action force. In response to the action force, equal magnitude of force is applied in the opposite direction and rocket just goes away. Okay, and clearing the gravity of the earth. So, students, in jet engines and rockets, the fuel is burned to produce a large quantity of hot gases. So, these hot gases, which are coming out of the rocket, okay, is what? Is with a great force, it's called action force. These outcoming gases exert an equal and opposite force on the rocket. This equal and opposite force on the rocket, hot gases applied over the rocket, and this is called your reaction force. And rocket then, yes, moves away, goes into the high into the sky, into the spaces. All right. So this is how rockets and jet airplanes work. Now, students, come to question number 4. How does a person move forward in swimming? Yes, I know that in this local area there are so many students who could swim, right? One of you must have that experience of swimming. You know that whenever you swim, you take your hand forward, okay, and pushing the water back in the backward direction. So whatever you are doing, you are first of all you are pushing the water, and that pushing the water is the action force, and those dragged water, all right, which you have pushed backward, is applying the force over your body. Now your body is going or moving ahead, moving forward. So this is how a person moves forward during swimming. Students, he pushes the water in the backward direction with his hands. A swimmer is called action force. Due to the reaction, the water pushes the person in forward direction with equal force. So this is what the answer, or we can understand the situation in terms of swimming, where Newton's third law is getting applicable. Now, question number 5. Why do you feel hurt in your hand when you hammer a nail into wooden plank? Okay, into wooden plank. What happened there? The force of the hammer on the nail is called action. Yes. Suppose that this is the nail and this is the hammer. So what are you doing? You're applying the force by hammer over the nail. This force is what? Action. Now reaction will surely comes back with equal magnitude of force. Yes, that's where you feel hurt in your hand. So the force of the hammer on the nail is action, and according to Newton's third law of motion, the nail exerts an equal force on the hammer, and this is the reaction force. Since the hammer is held in the hand firmly, the hand experiences the force due to the reaction and feels hurt. I hope every situation you have understood according to Newton's third law of motion. There are several situations from your daily life where Newton's third law gets applicable. Okay, so this is the situations we discussed. Now we are moving to the next topic about the conservation of momentum. Students, now here I am going to discuss about the conservation of momentum. We know and very much familiar with this term momentum. What is momentum? Momentum of a body defined as the what? Quantity of moving body. So students, now we are going to study about the conservation of momentum and what is the principle. Let us see. Principle. When two or more bodies act on each other and no external force acts on them, the total momentum of all bodies is equal to the initial total momentum. Students, I will give the complete explanation that what does this principle actually mean here. Students, you would have seen the collision between the two bodies, or you have seen or witnessed the accidents, road accident, usually, which is very common incidences in our India. It happens. So, students, we will discuss about that thing, that when a two bodies, like this body is A and this body is B. Okay, this body will have some mass, this body will have surely some other mass m2. Okay, and initial momentum u1, let us consider for body A, u2 for body B, and this is just before collision. This is just before collision. Alright, when these two bodies have not been collided, not come in contact with each other. So before collision case this is. Now what happens when these two bodies actually getting collided? During collision. During collision, students, this body A and this body B. Body A is applying the force on B, okay, in the form of action, force, and B is also applying the force in opposite direction with equal magnitude of force, and this is called a reaction force, and this is all happening during collision. Then what happens after the collision? After the collisions, students, again body A with mass m1. Now after collision, this initial velocity, which was u1 previously, will convert it into v1 for body A. Similarly, after collision, body B with mass m2, initial velocity u2 will be converted into v2. This is after collision status. Okay, students. So, principle of conservation of momentum says that sum of final momentum, okay, of two bodies equal to sum of initial momentum of two bodies. Sum of final momentum, alright, equal to sum of initial momentum. Basically, this is the principle of conservation of momentum. Now, go one more time about the principle. When two or more bodies act on each other and no external force acts on them, two bodies A and B, alright, before collision, this is the situation. They are at rest position, having initial velocity u1 and u2. Total momentum of all bodies, that means we are having two bodies. So total momentum of all bodies is equal to the initial total momentum. That means total momentum of two bodies after collision is equal to total momentum of two bodies before collision. So this is the principle which is written in this way, in the form of words. Okay, students, here during any collision we must understand the momentum is surely conserved. Momentum is conserved, but kinetic energy is not. This is happening. Why? Anybody who can relate with this? This is happening because during collision a part of kinetic energy is conserved into heat and sound energy. Yes. When two things are getting collided against each other, what happens? Students, sound energy gets created, or fire catching is quite possible between the two cars or two heavy vehicle or light motor vehicle. Yeah, there is so many possibilities of production of sound, production of fire catching in the form of heat. So there kinetic energy is getting converted into some other form of energy. Alright, so that is why we say here that momentum is surely conserved, but kinetic energy is not getting conserved. Kinetic energy is converted into another form of energies. Okay, right. Now I will show you numerically how could we do this and how could we understand this principle of conservation of momentum very fairly. Students, now we have come to prove this fact of the principle of the conservation of momentum. When two bodies collide, they exert force on each other, just now I have discussed. As a result, momentum of each body change. Okay, we can do one thing. We will understand few situations. This is body A, mass m1. This is body B, mass m2, and they are before collision. This is before collision state. So that means they are at rest position, having initial velocity u1 and u2 respectively. Okay. Now during collision, what will happen? They will apply forces on each other. So this is body A again, this is body B. So the force is applied by A on B and by B on A. That means FAB means force applied by body A on B, okay, equal and opposite force. So that is why minus I am writing here minus FBA. That means minus sign is just for showing the effect in the opposite direction of force. Okay, so that is why minus FBA. After collision, what will happen? They will again get separated. This is body A, M1. Now momentum is changed. So U1 will be converted into V1 for body A, and for body B, this U2 will convert it into V2. This situation is after collision of two bodies and got separated. Students, here if F1 and F2 are the forces exerted by the body 1 and body 2 on the other, respectively, we can say by applying the Newton's third law of motion. This is the case which will be coming out. Okay. Now here, for body A, momentum, that means momentum PA, before collision M1, U1. For body B, that means momentum B, M2, U2. This P means what? Momentum. B means body B. Okay. So what is the total momentum? Total momentum will be what? Total momentum PA plus PB equal to M1 U1 plus M2 U2. Alright. What will happen? Similarly like this, after collision, we will have PA dash plus PB dash. That means M1 V1 plus M2 V2. So these two total momentum after collision must be equal to total momentum before collision. This is the principle which actually explains itself in this way. Okay. Now, how could we do this, students? Let us see. Coming back to this relation, what relation we are having? FAB. FAB means what? Force applied by body A on body B. Okay. So we know that force is having relation of M into A. Okay. So here mass will be M1 and acceleration will be A1. So M1, A1, that means what? V1 minus U1 by T. V1 minus U1 by T. Surely this will be coming out now. What will be FBA? FBA, by following up the same thing, M2 into V2 minus U2 by T. So this is equation number 1, this is equation number 2, this is equation number 3. On putting 2 and 3 in equation number 1, okay, on putting equation 2 and equation 3 in equation 1, we get FAB, okay, that means M1 into V1 minus U1 by T, here M2 into V2 minus U2 by T. This TT will surely get cancelled. We will get M1 V1 minus M1 U1 equal to M2 V2 minus M2 U2. Okay, but have you missed one thing? Yes, this minus sign we have not placed. So minus sign will be put over right here. So this will give what? This relation. Next, M1 V1 minus M1 U1 equal to minus M2 V2 minus plus M2 U2. Okay. Now, final momentum and initial momentum will be kept all along with one side. So M1 V1 minus M2 V2, when it will change transpose to the another side, this will turn into M plus M2 V2, and this minus M1 U1 will convert it to plus M1 U1. That means M1 U1 plus M2 U2. So this is the principle of conservation of momentum, and we were supposed to prove this one. What is this? M1 V1, M2 V2. M1 is mass, body A, M2 is body B, and V1 V2 are explaining about the what? Final momentum. So total momentum after collision equal to total momentum before collision. So this is the principle of conservation of momentum which we discussed just now. I hope you have understood it very clearly. Okay, so no issues. This is very simple, and you could understand with your best possible resource, which is your mind. Okay, use that properly. Students, now I am going to discuss about the recoil velocity of a gun. Okay, recoil velocity. This is a gun. This is a bullet shot. Okay, what happens here in this incident we will discuss today. Just now we will discuss. We will wrap it up the chapter. Students, when the shot is fired from a gun, the gun recoils. Okay, gun recoils means what? When the bullet is coming out of its barrel, this is the barrel of the gun. When the bullet is coming out of it in the form of action force, okay, the gun recoils. Recoils means giving the jerk in the backward direction. Recoiling of gun. Recoiling of gun, and it is a reaction force. It is a reaction force, students, in the form of reaction force in the backward direction. So here, when the shot is fired, it leaves the barrel with a certain force, surely, and that force is action force. The outgoing shot causes a reaction on the gun, and it is an equal and opposite force acting on the gun, and it recoils. Students, before firing, both gun and this bullet shot are at rest. Okay, so initially, what is the total momentum? We will say nothing, absolutely zero. Yes. So before firing, total momentum total momentum of gun and bullet shot, since they are at rest, okay, at rest, so no momentum, it means 0. Let us consider equation number 1. Okay, now when the velocity of, what will be the total momentum after the what whole incidence, that means shot gets fired, what happens? So let us consider the mass of gun as capital M. Okay, mass of gun as capital M. Let mass of gun equal to capital M. Mass of bullet is small m. Again, velocity is being initiated here. Velocity of the shot when it leaves the gun. Okay, velocity of bullet when it leaves the gun, it means velocity of bullet in the simple way. So it is small v, I am considering here. Now velocity of recoil, that means that reaction force over the gun. So velocity of recoil, or recoil velocity rather you can say, of gun is capital V. So after firing there will be another momentum, total momentum will be something else. After firing total momentum changes to, now what is the momentum in the bullet? We will say m into v, small m small v, okay, plus, why plus? Because we are talking about the total momentum of these two things, gun as well as bullet. So capital M, capital V, this is equation number 2. Just now we were discussing about the principle of conservation of momentum, where it explained in such a way that sum of final momentum of two bodies equal to sum of initial momentum of the two bodies, right? So by following the principle of conservation of momentum, so from principle of conservation of momentum, okay, initial momentum, total initial momentum equal to total final momentum, that means mv plus capital MV equal to 0. So what is the recoil velocity? We are discussing about the topic, and this topic is what? The recoil velocity of the gun. Recoil velocity of the gun is this capital V. Okay, so capital MV, okay, is being taken to the left side, and this will going into the transpose into the right hand side. Sorry, minus MV. Now capital V equal to what? Minus MV by capital M. So this velocity is actually the recoil velocity of the gun, and this is the relation that we have deduced from here. As you can see, the negative sign, okay, this negative sign indicates the gun recoils in the opposite direction to that of the shot, to that of the bullet. Okay, here I hope you have understood this one very clearly, and today we have wrapped up this chapter, force and Newton's laws of motion. Hope you understood it well, and please prepare your copy. I will ask you to send those photocopies or those copies, clicking photos of the notes. So students, here we are wrapping up, finishing up this Newton's laws of motion. Thank you very much.